according to the Indian Road Congress IRC 115 code, which was released in the year 2014. Here, the most important thing what I want to convey is there are two softwares what I'm mentioning. One is called KGPBACK, and the second thing is called IIT PAVE. Without having the knowledge of IRC 115, okay, it is not that much understandable regarding the KGPBACK software or further analysis, whatever we do. See, actually, this presentation much covers about the IRC code fundamentals. So, and then afterwards, how to do the analysis with both the softwares KGPBACK and IIT PAVE. So, why we have to go for structural evaluation of Bituminous concrete pavement using falling weight deflectometer? And what is this falling weight deflectometer? In general, across the world, we know that there are two types of fundamental pavements called as flexible pavement. The second thing is called as rigid pavement. See, today we are concentrating on the session about the structural evaluation of bituminous concrete pavement. We have the same falling weight deflectometer analysis using the other code IRC 117 for cement concrete pavement also, which is called rigid pavement. That I will try to cover in the next session. Today we are concentrating on the bituminous concrete pavement, structural evaluation of bituminous concrete pavement. As we all know that already structural evaluation of the bituminous concrete pavement in the previous days was done using Binkelman beam deflection test. Most of the engineering colleges in India has this Binkelman beam deflection test, okay, in which we have a truck, okay, a Binkelman beam. We used to take the remote deflection, okay, at regular intervals, okay, and we used to actually based on the characteristic deflection what we got in traffic and MSA, according to the IRC 81, we used to calculate the overlay thickness what we have to do for the highway pavements. So that is a concept, but there is a need to modify that. Nowadays for overlay design in national highways, people are not test. What is the reason behind that, and why we have to use falling weight deflectometer for bituminous concrete pavement? There are several things what fundamentals we have to discuss. Then we will go to the KGPBACK and IIT PAVE software to complete the overlay estimation for a flexible pavement, which is also called bituminous concrete pavement. Now, my salient features of the lecture will continue like this. What is falling weight deflectometer, and why it is a need? What is the need for falling weight deflectometer evaluation of bituminous concrete pavement or flexible pavement in general India we call? So, what is the principle of falling weight deflectometer? Pavement evaluation survey and data collection, how we have to do it, all that. And most important thing is falling weight deflectometer is a very field evaluation is very simple when compared with the Binkelman beam deflection test. But the most important part of this lecture will be depend upon the most important things what you have to understand is analysis of data what you get from the falling weight deflectometer. That is most important. Next comes the estimation of design traffic, how we have to go for estimation of design traffic, followed by overlay design using KGPBACK and IIT PAVE software. In this picture, you can see clearly this is one setup, okay, called falling weight deflectometer, okay. So I think so this is a Karnataka based picture, okay. So you have the falling weight deflectometer. So it is not a towed vehicle, okay. It is attached with the complete. This vehicle is attached with the falling weight deflectometer. We understand first of all what is falling weight deflectometer. Then you can understand these pictures what I'm showing in a better manner. So this is a towered one you can connect to the vehicle. So what is falling weight deflectometer? First of all, falling weight deflectometer is a testing device used by civil engineers to evaluate the physical properties of the pavement in the highways. The falling weight deflectometer is used for highways. Similarly, we have heavy weight falling weight deflectometer for airport pavement design. And other than for low volume roads, there is another equipment called a lightweight deflectometer also. See, ultimately, we want to assess the physical properties of the pavement. What are the properties of the pavement, especially? See, nowadays we have, the elastic modulus or resilient modulus. Whenever we take the pavement structure, we have different layers. Suppose if I take the bituminous concrete pavement, we have from the bottom the subgrade layer, then afterwards granular subbase, okay, base course layer, bituminous base, and bituminous wearing course layer. These are the layers. Each layer is having its own elastic modulus, whereas nowadays, according to IRC 37 2012 and 18, we are calling for the surfaces which are having some rebound deflection, which are in elastic having elastic nature, we are taking into consideration that rebound elastic strain, and we are defining that as a resilient modulus. Okay, so the data acquired from the falling weight deflectometer is primarily used to estimate the pavement structural capacity. Structural capacity in terms of what? Actually, structural capacity. So basically, to say, whenever we talk about other countries like US and all that, they will determine some structural numbers and all that. But according to IRC, okay, 115, now I'm talking about in our conventions, how to understand the structural capacity like elastic modulus or resilient modulus and all that. So depending upon its design, the falling weight deflectometer can be contained within a towable trailer, or it may be built into a self-propelled vehicles such as a truck or van. This is a towed one, okay, trailer which can be attached to the vehicle and you can operate and you can. So how do you carry out the test using this falling weight deflectometer, and all we will see further. So the left side, whatever we are seeing is heavy weight deflectometer, which is used for structural evaluation of bituminous concrete pavement for especially airport payments. The right side, what we are using, this is lightweight deflectometer. It costs about, actually, falling weight deflectometer costs about crores of rupees, but lightweight deflectometer costs about 6 lakhs rupees. So nowadays, most of the engineering colleges, they are purchasing this lightweight deflectometer and carrying out some research work. Now, let me discuss about before going inside completely what is FWD. Let us talk about what is the need of this FWD over old method of structural evaluation of bituminous concrete pavement, that is a Benkelman beam deflection test. In the olden days, the overlay estimation of bituminous concrete pavement is done based on Benkelman beam deflection test, which is a rebound. We have the rebound deflection there because of the standard axle truck of 80 km. There, the characteristic deflection is obtained after correction for temperature and moisture of the deflections what you got. Okay, this is used along with the traffic in MSA for overlay thickness and design and all that. Okay, but this method now it is obsolete. Okay, so what is the reason for not using this? Basically, Benkelman beam evaluation, okay, test is it is a static load. Basically, it underestimates the strength of the DBM and BC layers. But thin layers Benkelman beam deflection test is good. But nowadays we are using some in highways, especially we have 150 mm thickness of DBM and as well as 40 mm of BC. The proper structural evaluation of what we call it is not we cannot estimate the structural capacity of a particular pavement which was constructed about 10 years before. Okay, now what sort of additional overlay thickness we have to lay and all that, we cannot decide with Benkelman beam deflection test, especially for highways where we're using thick DBM and BC layers. Okay, and another more serious limitation what we have with Benkelman deflection test is it is a static load test, whereas now whenever the moving vehicles are running on the pavement surface, we need to consider the dynamic load coming onto the pavement surface. Now this falling weight deflectometer, by means of this, we are going to apply the dynamic load on the pavement surface and we are going to measure the deflection. So that is the main advantage of falling weight deflectometer. Okay, it takes into consideration of the dynamic load which is coming onto the pavement surface. You know that the wheels will be rolling on the pavement surface. So whenever it is rolling on the pavement surface, we are having some dynamic action. So that it could not, Benkelman beam deflection test could not take into consideration, and it underestimate the strength of a DBMD series. For that reason, we are going to follow this. Now, this is the standard thing. Already most of the engineers in India, they used to conduct this Benkelman deflection test. Even the engineering college, most of the people have this equipment. So people use it to conduct this Benkelman beam deflection test in the site. Okay, this is just I want to show the picture. I'm not going much into IRC 81 once again. Now, what are some of the fundamental basics whenever I talk about FWD? FWD, falling weight deflectometer data, is most often used to calculate the stiffness. Stiffness, that's what I'm talking about, elastic modulus or rigid modulus. Related parameters of pavement structure. The process of calculating the elastic modulus of individual layers in a multi-layer system is based on surface deflections. So once, see, by using the falling weight, what is meant by falling weight actually? Weight is falling from certain height actually. Okay. So ultimately, whenever the load falls from certain height, okay, you are going to have some deflections. Okay. Here in the falling weight deflectometer analysis, we are going to release that 40 kilonewton. Why 40 kilonewton? Our IRC standard axle load is 80 kilonewton. Half of that is 40 kilonewton. So we want to measure, okay, that 40 kilonewton load that is coming on the pavement surface in a dynamic manner, and we want to measure the deflection by means of some transducers or geoforms, which we will discuss further. So ultimately, after calculating the deflections, we are going to correct them. We are going to correct them for 40 kilonewton. Whenever we are releasing load from certain height, we may not get always 40 kilonewton. Here there is some sort of discussions. We will go in through deep in through. Okay, deep process. We will understand what is what and all that in further slides and all that. Instead, initial modulus. See here in this falling weight deflectometer analysis, once you get that whatever the deflections what we have, what we get from the site, we will correct them for whatever linearity and some sort of temperature and moisture corrections, and we will use a back calculating software. Okay, back calculation software which is based on genetic algorithms. It is an iterative process by means of which we are going to get the elastic modulus of the pavement. So here we are going to give some seed values. Okay, so the seed values of the elastic modulus were suggested by IRC according to the pavement condition. Okay, whether the flexible pavement condition is good, whether it is bad, completely poor in condition, or fair in condition. Depending upon that, IRC has suggested some sort of modulus values. Using that, we are going to use KGPBACK software, and we are going to back calculate. It does back calculation in iterative process, and when the error percentage is very less, it will give the correct elastic modulus of the particular layer. This process, that's what I'm telling. This process is computationally intensive, although quick on modern computers. Generally, we have globally different softwares. Okay, so one is called L-mode, Dynatest. Dynatest is the manufacturer. Okay, of this equipment called as falling weight deflectometer, and KGPBACK is our Indian software. One such back calculation software has been developed by the Transportation Engineering Division of IIT Kharagpur, Professor K. Sudhakar Reddy, IIT Kharagpur. So under his research work, they have developed this software, and in US, and by Michigan State University, MICHBACK is one software they're using. Now we will discuss about this falling weight deflectometer, some other basics. When a moving load passes for the pavement surface, it produces load pulses, normal stresses, vertical stress as well as horizontal. Okay, so it is not only just a static load. So as I told, the dynamic loading is dynamic load is moving on the pavement surface. Okay, so for that reason, we are going to people have introduced the falling weight deflectometer. Okay, so normal stresses at a location, the pavement will increase in a magnitude from 0 to a peak value as the moving load approaches the location. See, always whenever the load is exactly the point where you are measuring the deflection, it will be very high. And moreover, as the load moves in the forward direction, so the deflection definitely will come down. Okay, the deflection value will be very high when the load is very close to the location. As progresses, the deflection value will reduce. The time taken from the for the stress pulse to vary from 0 to peak is called rise time of the pulse. As the wheel load moves away from the location, magnitude of the stress will reduce from peak value to 0, as I have discussed. Okay, so stress is more, deflection will be more. Once the load moves forward, the deflection will reduce. The time period during which the magnitude of the stress pulse varies from 0 to peak is the pulse duration. Now, peak load and corresponding pavement surface are interest for the pavement evaluation. Now, what is the peak load in India? As I told, according to the IRC, okay, standard axle load, we have 80 kilonewton IRC standard axle load. So we are taking half of that because the either half will produce the same stress on the pavement surface. So we are taking 40 kilonewton. So what is the working principle of falling weight deflectometer? During testing, the falling weight deflectometer subject the pavement surface to load pulse, which simulates the load produced by rolling wheel load vehicle. That's what we are talking about, rolling wheel vehicle. The load pulse is produced by dropping a large weight onto a buffer. If you see this image, we have spring system. So the falling, so we have a mass which is raised by certain height, okay, and it is released. So it will fall onto that spring system and it will apply onto the pavement surface. So it is. We will thoroughly discuss about what is the dimension of that loading plate. If you see here, we have deflection sensors, we have loading plate, we have spring system, we have falling mass, everything. What are the configuration, for the dimension, all that we are going to discuss in the coming slides. So data are required from the various sensors used in post-test analysis of the pavement properties. The deflection sensor are used to measure the deformation of the pavement, respond to the load pulse. Now, different magnitudes of impulse load can be obtained by selection of suitable mass and appropriate height of the fall under the application of the impulse load and pavement deflects. Now, velocity transducers on the pavement surface at different radial locations measure the surface deflections. Now, here geophones are used as displacement transducers. Load and deflection data are acquired with the help of data acquisition system. Actually, whenever people are using falling weight deflectometer, so data acquisition system will be there. So whatever the load applied and corresponding what we call the displacement from the geophones, as I have shown you in the previous slide, we have, if you see here in this picture, whatever I'm showing, deflection sensors are located at a particular interval, exactly below the load you have, and at a distance, a radial distance, we have something like 300, 600, 900. IRC has specified some location for Indian conditions, okay, and we have to follow that. So typical falling weight deflectometer include a loading plate of 300 mm or 450 mm in diameter. In these guidelines, 300 mm diameter plate is recommended in IRC. And moreover, here the most important, a rubber pad of 5 mm minimum thickness should be glued to the bottom of the loading plate for uniform distribution of the load. And the most important concept, see, as you know that 5 mm rubber pad will be attached to the circular plate for the uniform distribution of the load. That is okay. But other than that, if it is a single plate, whatever we are calling the plate, okay, if it's circular loading plate, whatever you're talking about, if it is a single plate, sometimes there will be sitting problems and all that. The reason is, if we have pavement surface, pavement will always have some camber or sometimes cross slopes and all that. So if it is a single plate, the pavement and the loading plate cannot get into contact properly in contact. Until they both don't have proper contact, load cannot be applied. For that reason, segmented loading plates are now the falling weight deflectometers have segmented plates. Segmented means the two parts, such that these can properly load onto the pavement surface without having any contact gap and all that, for a better load distribution. That is the concept. Typical falling weight deflectometer, as we have discussed just now. Okay, we have this and all that, and alternative segmented and all we have discussed. A falling mass in the range of 50 to 350 kg. Actually, according to IRC 115, a mass of 50 to 350 kg is dropped from the height of the fall in the range of 100 to 600 mm to produce the load pulses of desired load and duration. Now, actually, our target is to produce a peak load of 40 kilonewton. As we have discussed about IRC standard axle, we need that 40 kilonewton. But whenever we apply the load onto this from a certain height of what we talked about 100 to 600 mm, sometimes the load applied on the pavement on that spring system mass, okay, the load applied on the pavement surface may not be exactly 40 kilonewton. It will be sometimes plus or minus 4 kilonewton, okay, which correspond to the load on one dual set of wheel set of 80 kilonewton standard axle load. Now, whenever we are getting some value other than 40 kilonewton plus or minus 4, we have to, okay, get the deflections interpolating in a linear manner. So whatever the load you are getting and deflections you are getting from the side, they are automatically automatically detected, and you will get the results. But later afterwards, you have to linearly interpolate the results for 40 kilonewton, and you have to compute, you have to correct that whatever the deflections you taking that 40 kilonewton as the standard thing, you have to linearly interpolate the deflections. That process we will discuss in the coming slides. The target peak load can be suitably decreased suitably if the peak maximum central deflection measured exceeds the maximum deflection. See, sometimes you are getting these are all some sort of adjustments what we can make. The target peak load can be decreased suitably if the peak maximum central deflection measured with 40 kilonewton exceeds the measuring capacity of the deflection transducer. Similarly, the load pulse can be increased to produce deflection at least 10 micrometer at a radial distance of 1.2 meter. These are all some adjustments. Here I'm not much discussing about that calibration of Falling Weight Deflectometer. I'm just concentrating on what is the working principle and how we have to go for analysis part for that. So if the applied peak load differs from 40 kilonewton, the measured deflection has to be normalized corresponding to standard target load of 40 kilonewton. So that is just now I am discussing. So you have applied by means of Falling Weight Deflectometer some sort of, as I told that 40 kilonewton always you will not get because we are raising some mass up to weight of 350 kg and we are leaving up to from a height called 600 mm. So sometimes you may get 41 kilonewton or 42 kilonewton or 38 kilonewton plus or minus 4 kilonewton. So you have to normalize the deflections whatever you get linearly for 40 kilonewtons. This is one of the most important thing what you have to keep in mind. So sufficient number of deflection transducers should be used adequately to capture the shape of the deflection bowl. This is very much important. What is this deflection bowl? As you have seen in the previous slide, deflection bowl is always we talk about. So if you see here, we have deflections D0, D1, D2, D3, D4, D5. Now here we have the deflection shape like this. So this is called deflection bowl. Okay. So we will discuss further in a detailed manner regarding the deflection bowl. So sufficient number of deflection transducers should be placed to adequately capture the shape of the deflection bowl. Just now I have shown you what is the deflection bowl. So you have to place the number of deflection transducers to exactly capture the shape of the deflection bowl. So 6 to 9 velocity transducer geophones are generally used for measuring the surface deflection of the flexible pavement. So deflection sensors are placed on the surface of the pavement in radial direction, aligned in the direction of the longitudinal direction. Okay. So I will show you one video based on this, how basically these geophones are placed, how the load is applied. So generally in radial direction, these geophones are placed. Okay, and all that we will discuss. So typical geophone configurations. Okay, IRC suggested generally 7 sensors we have to place. So these are at distances of 0, 300 mm, 600 mm, 900 mm, 1200 mm, 1500 mm, and 1800 mm at radial distances. Now here you can see. So once again, the same picture what I have shown you. This is a deflection bowl. So here, one of the most important thing what you have to understand is the deflections, whatever we are getting at D0 up to D8 are the surface deflections. Okay, the deflection we are getting is because of the combination of these layers. Okay, HMA is hot mix asphalt. Okay, and other layers. Okay, it is a surface deflection what you are not measuring. It is a surface deflection you are measuring. It is not a deflection of a subgrade layer when the load is applied like that. Okay, the pulse time is generally 20 to 30 milliseconds when the load is applied and all that. So we are measuring the surface deflections only because of the combined. We have the combined structure of the different pavement layers like subgrade, base, and subbase, and top bituminous concrete pavement layers. Now further, whenever we discuss, okay, so what are the other things what we have to keep into? Just 1 minute. You are able to see the slide title, participants?
Yes, sir. Pavement evaluation survey and data collection.
Okay. Then that is good. Okay. So the following are the broad categories of surveys and investigation data collection exercise. So whenever you want to go for structural evaluation of bituminous concrete pavement, it is several things what we have to understand because the structural evaluation, whenever you're going for the site, there are some sort of things keep into mind. Surface failures will be there, structural failures will be there. There are different types of failures. Okay, sometimes falling weight deflectometer analysis is not needed. Sometimes, okay, whenever you are doing structural evaluation. Okay, so the different failures of the flexible pavement includes we have potholes, some sort of rutting and all that sometimes. Okay, so rutting is a mixed failure basically. Okay, it doesn't come under structural failure. Suppose let us say if I talk about transverse cracking or longitudinal cracking. So cracking, if it's a crack width exceeds, okay, something like a 3 mm, we will discuss about in detail in further presentation. So it is most important to understand surface failure. For the surface failures, there is no need of going for a falling weight deflectometer analysis. Only if structural failures are there, then how to improve the performance of the existing bituminous concrete pavement. In that case, we should go for this falling weight deflectometer analysis. So the following are the broad categories of survey investigation data collection exercise. So you should know the historical data about the pavement. That is most important. Okay. So condition, a survey of the pavement for identification of uniform sections, what we call homogeneous sections you have to identify for similar conditions. So deflection measurements, how to do using falling weight deflectometer and pavement layer thickness and composition and subgrade characteristics without understanding the pavement in a detailed manner. Historical data of the pavement, that is most important. Let us discuss about that first. Historical data of the pavement. So when the pavement was constructed, first of all, what type of layers they have constructed, how much thickness, and what is the strength of that layers, different layers, what. So what is the properties? See, properties means what is the resilient modulus of the granular layer or bituminous layer, what they used. Okay, so what is the CBR value of the subgrade layer? Everything. See, we have to take care historical. First of all, whenever we are using falling weight, before going for falling weight deflectometer, whether we have to go or not, thorough understanding of the existing bituminous concrete pavement, which was constructed some 7 or 10 years back. Okay, so definitely we have to understand the pavement in a detailed manner. The data regarding functional and structural evaluation carried out the existing surface is overlay. Okay, see, whenever we talk about pavements, we have two things. Okay, one is called functional and the second thing is called structural. Okay, so these are two different. Okay, so functional means just what is the function of constructing a bituminous concrete pavement or any overlay and all that to provide the riding comfort. Whereas structural means structural performance. Structural performance means the pavement what we have constructed should take the load in a smooth manner and it has to transfer the load to the bottom layers without any failures. That is most important. So functional evaluation includes proper riding comfort, okay, whether the passenger are feeling comfortable or not. Okay, so before going for any sort of structural evaluation of a bituminous concrete pavement, which we call flexible pavement, we have to go for thorough understanding of the existing pavement, where we have to go for some sort of laboratory testing on the results on different materials used and all that even. Okay, so what type of failures are there? So whether it is pothole or we have rutting or something like you are getting cracks. Okay, what type of cracks? So wide cracks you are getting, and what type of material you use, what is your subgrade material. So whether what is the classification of the soil, whether it is a clay sand you use or silty sand you use, what is the CBR value, what is the plastic limit, because the flexible pavement or bituminous concrete is such a pavement, if you have and some sort of volumetric difference in the bottom layers, as it is, it will reflect to the top of pavement surface. So for that reason, okay, so soil is going to be very much a fundamental material. Okay, you have to have thorough understanding about the plastic limit. Okay, what is the liquid limit, plastic limit, and all that. So because you have high plastic index, so definitely the failures will be different. So understanding the failures is very much important. Without understanding the pavement condition, without understanding the pavement layers, what are their strengths, okay, what are the failures. So you have to thoroughly understand what is the reason for the failure. Okay, so and for such failures like rutting and potholes, there is no need of a falling weight deflectometer. Falling weight deflectometer analysis, okay, for overlay estimation. Okay, it is for to go for whenever the pavement is having some structural failures. So we have to historical data collection is very much important. A thorough historical data of the existing bituminous concrete pavement for every kilometer of the pavement what you are visiting the site, you have to take, that is very much important. Okay. In which year the pavement was constructed, as what are the internal and external drainage arrangements made. Okay, as you know, the subbase, granular subbase, which is a drainage layer. So properly the water, whatever it is entering camber is properly provided, and moreover the subbase layer, it is properly draining of the water. Everything has to be ensured, proper drains are constructed. So as the constructor, other than that, what are the construction methods adopted, and what about the quality control test, how the results they are getting and all that. Maintenance and rehabilitation data as such as the past distresses, effectiveness of different maintenance and rehabilitation measures undertaken in the past. See, some sort of pavement was constructed in the year something like 2010. After 7 years, something happened. Now, some sort of overlay they have made, and after that, some sort of distresses have came. Now, you have to collect everything, the data, and you have to understand after 7 years of the pavement construction, what sort of failures were came, and what will be the reason for that failure. And before going for another overlay, okay, it is very much important to understand the historical data like this, and try to get some conclusions. Try to get some conclusions. What is the reason for the particular failure? That is very much important. Okay, whether it is a surface failure or structural failure, this is very much important to understand. Without understanding whether it's a structural failure or surface failure, going ahead with falling weight deflectometer is it is not correct. As I told, falling weight deflectometer I told cost is about crores, 2 crores, 3 crores, like that. And when it is a surface failure, there is no need of going for that analysis. And climatic condition, you know that climatic condition is very much important. As you know that monsoon, especially monsoon season, heavy rains will be there, and your subgrade layer, bottom layers completely get submerged in a condition. And definitely poor soil materials are there. Definitely it will affect the condition of, it will lead to failure of the pavement. So temperature, even the temperature, suppose let us say if we take Rajasthan, temperature is very high there, 45, 50 degrees, 55 degrees. So your bituminous concrete pavement top layer will have that, because of that temperature, definitely the resilient modulus or elastic modulus will the strength they will lose. Sometimes you're using poor mixes, a lot of rutting will be there. When I'm working with Kishangarh, Udaipur, Ahmedabad of Rajasthan, I have seen in the wheel part direction, a lot of rutting. You know what is meant by rutting, okay? It is something like a 20 mm vertical depression along the wheel part direction. So several things we have to understand. What is the past traffic volume, history, how much traffic is coming on applying in that road, okay? Earlier, whenever you have designed the pavement, maybe it may be 100 MSA. Now the traffic has increased more additional 50 MSA traffic is coming. So to consider that, so what we have to do on that. So traffic history is also very much important. Axial load spectrum. So what type of loads are coming? Whether it is only tandem and tridem axles are coming. So you have to this axial load spectrum is very much important to estimate the vehicle damage factor. You know, VDF in pavement design, flexible pavement design in IRC 37, 2012 or 2018 or the basic 2001 version. So for calculating of MSA, so VDF is very much important vehicle damage factor. So we have to take that axial load spectrum. We have to conduct this axial load survey test in the field. Okay, using the weighing pad, you have to get the data and you have to analyze and you have to finalize the VDF value, vehicle damage factor. You know that we never expect always a standard axle of 80 kilonewton will come onto the pavement surface. IRC has considered 80 kilonewton, but never always 80 kilometer standard axle with a set of dual tires on both sides. A standard load will come onto the pavement surface, but we expect more heavy weights. So using the fourth power damage law, we will try to calculate that vehicle damage factor. Sometimes you don't have you don't have the chance to conduct the axial load survey. IRC has specified in the codes, pavement design codes, to take the VDF values. So discussion with the engineers, that is very much important before going for any sort of structural complete evaluation. So discussion with the engineers associated with the project, okay, that is also very much important, which can give some valuable information regarding the structural evaluation. Now, pavement condition survey. Pavement condition survey shall precede the actual deflection measurement, and it consists of primarily visual observations supplemented by measurements of estimation of the cracking, rutting, and other distances pavement. Okay, pavement condition survey is very much important. So whenever we used to work for national highways or expressways or somewhere, we used to walk in the olden days. Nowadays, network survey vehicle is there. So network survey vehicle, it is automatically it is capturing the failures of the image by means of images. It is capturing. So people are easily analyzing what type of failure was there in the pavement surface. Okay, so whether it is a crack or what is the width and all that, everything they used to manage by means of network survey vehicle. But in the olden days, people used to walk on the pavement surface for a number of kilometers, and they used to understand the distresses. They used to mark on the mark on the sheets, and they used to write what type of failure it is and all that. So it may be prudent to identify some possible cause of distresses using condition survey and other investigations such as coring test pits, laboratory testing before conducting extensive deflection measurement using Falling Weight Deflectometer. See, that's what I told. Whether it is a mixed failure, what is the problem and all that, that is most important what we have to understand. For that reason, sometimes we have to take the course. So before going for this major Falling Weight Deflectometer analysis, we have to understand the pavement, what is the possible cause of distress. Okay, we can go for such investigations such as coring. So take a core, okay, take the laboratory and estimate what is the density and other tests, whatever you can do, stability analysis and all that. And you have to take the test pit. Test pit is very much important in structural evaluation. Okay, whenever in the olden days BBD test was conducted, even in that case also test pits were conducted. Test pit is something like you are making a pit on the right side or left side of carriageway. Staggered manner is always better. Okay, staggered manner is always better. You need to understand what are the different layers. Okay, how much thickness. So just and what is the soil? Sometimes we used to conduct the site CBR test, which was dynamic cone penetration test. So you can directly conduct the dynamic cone penetration test on the subgrade soil sample, and you can determine the CBR and further elastic modulus of that subgrade layer. Okay, if the distress are not related to structural capacity of the pavement layers, the Falling Weight Deflectometer may not be of much help. So that's what I told. Rutting in bituminous mix, distress caused by stripping in mix are the situations in which structural condition of the pavement may not be necessarily explained adequately by FWD measurements. So the information collected in the condition survey should be relevant, adequate for identifying sections of uniform performance for the purpose of determining the sample size for the deflection. See, ultimately here we have some 10 kilometers, okay, of the stretch. Whenever you went to the site and you seen all the 10 kilometers will not have the same failure. Okay, the failures will be different. Some section may be first 1 kilometer may be good, some other section may be fair, something other section may be poor. So for that reason, the homogeneous section for overlay design is one of the most important thing what you have to finalize based on the deflection bowl measurements, whatever we make. We will discuss further. This is based on the always this homogeneous sections will based on the traffic subgrade characteristics. Say subgrade what material they have used, that may not be same in all the kilometers. Sometimes the soil may change, okay, and based on the deflection bowl, whatever you are getting, that may not be same in all the kilometers. Suppose you take the 10 kilometers, you will not get the same deflection bowl in all the 10 kilometers. So we will discuss how to go for these homogeneous sections in further slides. The condition data will would help you to figure out the cause of the distresses, some of which could be treated as by non-structural treatment like sealings, slurry surfacing, cold planning, and replacement of unsound materials. So this will make functional loss and prepare the pavement for receiving the structural overlay. Strengthening of flexible pavement should not be adapted without restoring its functional loss. Okay, so further suitable mapping format should be used for mapping distresses data. Okay, so you have multi-lane payments. Okay, so you have to divide whenever you are going for this Falling Weight Deflectometer. If it is needed, that is most important. If it is needed for structural evaluation using Falling Weight Deflectometer, when serious structural failures are available, then only you have to go for FWD. And whenever you're having multi-lane pavement, it is always better to divide into blocks of 50-meter length, because and one lane width always 3.5 meter that is considered. So you know the distresses. The distresses are different types, as I mentioned: cracking, rutting, shoving, bleeding, stripping, raveling, pothole, patching, etc. So always you have to understand what is the severity of distress, extent of distress, location of the distress, everything. Okay. Now, whenever we have decided that we have to go ahead with Falling Weight Deflectometer, that is very much important. We understood the structural failures are there, but how you have to decide whether it is the condition of the pavement is fair, whether the condition of the pavement is good or fair. These are the IRC has given some sort of what we call observations what you have to make from the site, so that you can decide the section is good. Suppose let's say whenever I have decided it is good, you should have some isolated cracks of less than 3 mm width, okay, in less than 5% of total paved surface. 1 kilometer I took, okay, in that 5% of area is having less than 3 mm width cracks, okay, and red depth less than, average red depth less than 10 mm, then I can consider that good. And fair, isolated or interconnected cracks of less than 3 mm width in 5 to 20% area of total paved surface, and or average red depth between 10 to 20 mm. So these are all the what we have to follow IRC recommendations. Okay, so IRC recommendations without following doing FWD analysis and all that is not correct. Thorough understanding of IRC 115 for structural evaluation of bituminous concrete pavement is very much important. The PPT whatever I have made is completely from IRC 115. Okay, I am explaining all the things, because without knowing all these things, doing FWD analysis and using some software and getting the results is having no meaning. So poor, when we have to consider the surface of the pavement is poor, so wide interconnected cracks are there more than of 3 mm width, okay, and 20% area. Your pavement complete, you take 1 kilometer, 20% of the area is having this problem, okay. So definitely you have to consider this as, and red depth is also more than 20 mm. Same, these are all the criteria for failure what they have given in IRC 37, 2012 and 18. Now deflection measurement. Now we know that now we have decided that we have to use Falling Weight Deflectometer for structural evaluation as some deep cracks. Already we have seen this is the pavement is going to have failures. Okay, already the pavement was constructed some 10 years back or 7 years back, so it needs a overlay. Definitely we have decided. Then we have to go for how many samples. Okay, estimation of the samples. So now how many samples you have to take on the pavement surface by using the falling weight deflectometer. So this is a statistical distribution thing what they have given, number of samples, how we have to consider. Okay, using falling weight deflectometer. So here n is equal to z into CV, coefficient of variance. Z is a statistical parameter, and you normalize normal deviate, which can be obtained from standard statistical tables actually. Okay, based on the confidence interval. We have 95% confidence interval, 90% confidence interval. I will show you the next slide how to take this number of samples per 1 kilometer and all that. So here M is acceptable margin of error. If you see here, IRC has recommended 90% confidence interval and 10% of margin of error. So that may be considered for estimation of the sample size. Now this is this I have took from the presentation given by Dr. Anush K. Chandrappa. Okay, he has given this presentation to GMRIT and BVRIT FDP. That FDP has the title of design and construction practice of sustainable payments. Okay, here the same formula whatever I have shown there, here it is there. So generally this good section we will take the coefficient of variation as 15%, fair section we will take 30%, poor section we will take it as 45% the coefficient of variance. And how that based on 95% confidence interval in the case of good section. Okay, so basically you per 1 kilometer how many samples you have to collect actually using falling weight deflectometer. So just you can go ahead with the 25 samples here. Similarly, 90% confidence interval, how many samples have to go and all that. Okay, so like that. And what is the interval of measurement? Interval of measurement, once you know the samples in the longitudinal direction, you can calculate. Okay, 95% confidence interval means you have 25 samples, 1000 divided by 25, you get 40 meters. So 90% confidence interval, it is 250 meters because it is 1000 divided by 4, 250 meters. Similarly, for fair section and poor section, how to take the samples. And moreover, one important observation what you have to make is, so as the you are going from good section to poor section, the number of samples what you have to take will increase. Definitely we have to take more number of samples to understand so what deflections you are getting, because we are going to back calculate what is the resilient modulus or elastic modulus of the pavement by giving the seed values based on the deflections whatever we are getting by using the falling weight deflectometer. So Dr. Anush K. Chandrappa is assistant professor of IIT Bhubaneswar. He has delivered a session for that design and construction practice of sustainable payments, which was organized by GMRIT. So I took this slide from his presentation. But other than that, in longitudinal direction, how to measure where at what interval I have to take and all that the reflection measurements. So IRC has specified some distances. It all depends upon whether what is the type of the carriageway, and moreover in longitudinal direction the test should be the maximum spacing. If you see, observe here in the wheel path direction, these all the longitudinal direction, how you have to conduct the test at what interval and all that in longitudinal direction, wheel path direction. So based on the type of the carriageway, so how you have to conduct the test, at what location you have to conduct the test, that it is given in IRC, that IRC 115. So until unless you don't see IRC 115, you cannot understand how to go ahead with the falling weight deflectometer analysis. So if it is single lane two-way carriageway, measure along the both outer wheel paths. A single lane road 3.75 meters. Okay, you have, and definitely both the outer wheel paths. See, wheel path, how do you know? First of all, whenever you go to the site, if you observe, especially on the flexible pavement, impressions will be falling on along when the vehicles are moving on the pavement surface, impressions will be there. So generally wheel paths you can consider like that, or you can follow some distances what they are given, especially in the next slide, from the outside, what we call at what distance from the outer edge of the pavement, at what distance you have to take and all that, some guidance was given. So this table gives the clarity. Okay, So in longitudinal direction, along that what we call wheel path direction. So depending upon the condition of the pavement, whether it is a poor or fair or good, so how to take that interval, okay, depending upon the type of the carriageway and condition of the pavement. So I'm not much concentrating here because some other analysis part I want to explain. So just I'm going ahead. So these are some pictures where you can understand how to measure the deflections in the field. Okay. So as we know from the outer edge, some constant, some distances we have to consider, minimum some distance. As I will show in the next slide also. This slide shows you, okay. So from the outer edge of the pavement, when it is a single lane two-way carriageway, okay, it should be some 600 mm from the outer edge of the outer lane. Okay. So outer edge of the outer lane. Okay, if it is a single lane two-way carriageway, two-lane two-way carriageway, and for multi-lane carriageway, it is 1 meter from the outer edge of the outer lane. Okay, outer lane means it is towards the shoulder. Okay, that is most important. What you have to understand. So at what location you have to conduct the test? That is very much important. It all depends upon the carriageway and all that. So for divided carriageways with 2 or more lanes in each direction, it is a 0.75 meter. That is 750 mm from the outer edge of the outer lane. So sometimes we need to conduct the falling weight deflectometer test based on the failures whatever we are observing. So sometimes we have to go conduct on inner lanes also. So outer wheel path of inner lane. Okay, and multi-lane single carriageway at 4 meter from the outer edge of the outer lane. Similarly, for divided carriageways, okay, with 2 lanes, okay, in each direction, 4.2 meters from the outer edge of the outer lane. So these guidelines you can follow. Now, what should be the data that should be recorded whenever you are going for falling weight deflectometer test at a particular location? Okay, this is very much important. You have to go for chainage. That is very much important. At what chainage you are conducting? Some 385 plus 000. Okay, you take NH is having some changes. Okay, now you take NH 16 or whatever the NH, it is having some chainage. Okay, so chainage is very much important. Some 285 plus 345. Okay, position of the lane in the carriageway, whether you are doing an outer lane or inner lane. Now transverse position of the test position in the lane. That's what I have told. We have to follow some interval, longitudinal interval as well as transverse. Okay, at what distance you are measuring and all that. Measurement spacing, how much spacing you conduct the test. Time of the test. Okay, I will discuss about the time of test in the and temperature and all that in further slides. Air temperature is very much important, and the pavement surface temperature is very much important. For this, basically, we have to pavement temperature. Whenever you are measuring, you should not measure its surface. You have to just measure that at a depth of some 40 mm and all that. So drop number. So how many drops you have made that we using falling weight deflectometer, and peak values of loads and deflection for each drop of the load. Now whole time history of the load and deflection should be stored for one test. Okay, you have conducted one test, so whole history of the load and the automatic. See, we have all automatic what we call detection things. Okay, you will get properly the load and what deflections, what you will get. Automatic systems are there, but you have to save these things. Points of each road section. Deflection transfer configuration selected. So number of sensors you use and what radial distances from the load, center of the load and all that. And last one, what is the loading plate diameter? As I told, 300 mm is preferred according to IRC. Okay, steps for measuring the deflection at a point. Okay, mark the test point first of all by means of chalk piece and center the load, the plate duly calibrated. FWD calibration I'm not discussing much. Lower the loading plate on the pavement surface. There should not be any standing water on the pavement surface. So loading plate should be in proper contact with the pavement surface. That is very much important. A rubber pad of 5 mm we are using at the bottom of loading plate to have uniform distribution of the load. When the load is the mass, it is some sort of load which is dropped from a certain height. Okay, it should be properly that load should be distributed among, then only distributed, and then only you get the proper sensor deflection. So if it is a non-segmented plate is used in the presence of rutting at a test location, should be noted if it affects the contact between the plate and pavement surface. See, we have some sort of slopes, camber like that, or some sort of what we call slopes and all that. In that case, we did segmental plate. Okay, it is a one circular plate. That's what I told in the previous case also. So lower the flame loading and displacement transducers so that the transducers are getting to the pavement surface, contact with the pavement surface. So here, how to conduct the test, steps for measuring the deflection test point. Raise the mass to a predetermined height of something we have taught over 600 mm height, and you have to release the load such a manner that we need some 40 kilonewton, but you need always get 40 kilonewton. That correction I told that we whatever the deflections whatever we get, we have to go for normalization to the 40 kilonewton load. So drop on seating load, load and deflection data for seating load are not to be recorded. Seating load means proper contact should be there, that you know already. Raise the mass and drop record the load and deflection in the computer through the data acquisition system. So while peak load and peak deflections at different selected radial positions must be recorded, and complete time history of the each load drop if feasible. Okay, repeat the test at least 2 more times. So see, we need some confirmation whether we are getting the same deflection. So if during the steps, okay, the deflections are measured too large or too small, the test may be repeated by changing the peak load. Okay, so raise the geophone frame and load plate and move to the next location. Okay, so once you complete at a particular one location, so just you can raise that geophone and you can move to the further location. Record air temperature. That is most important at every half-an-hour interval. I will discuss about the temperature because this FWD analysis it should not be conducted when temperature is more than 45 degrees centigrade. So some temperature considerations are there. Definitely we'll discuss in the further slides. So record the pavement surface temperature. Temperature also that also at regular intervals. Okay, time intervals. That is most important. So measure the pavement surface temperature at half-an-hour intervals. Okay, by drilling 40 mm that I told already. Okay, you have to fill that with a glycerol. Okay, and using thermometer you can measure that. The deflection, the FW deflections should be never measured when the temperature is more than 45 degrees centigrade in summer. That's what actually you have to prefer to conduct this test in summer, especially whenever you're doing so something like time period between morning 6 and around 10 o'clock. And evening after 4 o'clock, and you can continue the test in the night. So in colder areas of altitude greater than 1000 meters, where the average daily temperature is less than 20 degrees for more than 4 months a year, the standard pavement temperature of 35 degrees will not apply. See here, pavement temperature, it is generally considered, even in the IRC 37/2018, standard pavement temperature generally considered 35 degrees centigrade. Here also the same temperature is considered. But whenever we are considering some colder regions, you should not consider 35 degrees centigrade as a standard. It is recommended in those locations where temperature in colder locations where temperature so it is recommended deflections in such areas will be made with an ambient temperature greater than 20 degrees centigrade. So no need to apply the temperature correction for the modulus of the bituminous layer in this case. See, basically we are going to apply 2 types of corrections. One is temperature correction for the elastic modulus, whatever you get for the bituminous layers, and moisture correction you are going to apply for the granular layers as well as subgrade layer. These 2 are the corrections. Actually, in colder regions, especially when temperature is something around ambient temperature is just greater than 20 degrees centigrade and all that, so there is no need of any temperature correction. What you have to apply for the elastic modulus, that we will see. Okay, further. Now just I'm going to play this video so that you can just have. So this is how the mass is raised to a predetermined height. It is released onto the pavement surface. So the geophones are used to measure the deflections, and now once the test was completed, it is lifted up like that and it is continued to the next location. Now further determination of the pavement layer thickness. Okay, so basically you have conducted the deflection test, but you at every 1 kilometer, okay, you should know you know what are the structural failures. You should know what is the exact pavement layer crush thickness what they have laid. Okay, that is very much important. See, we are going to back calculate the elastic modulus. Okay. So for that, you need exact pavement composition, whatever it is there, where at what location you have conducted this falling weight deflectometer test. So pavement layer thickness are very essential to inputs to give the process of back calculation of the layer moduli, and in turn to estimate the remaining life and overlay requirements of the in-service pavement. Hence, it is necessary to accurate information to be collected about the layer thickness from the different sources. See, this can be obtained from historical data. You know what pavement thickness was constructed, or by coring the bound layers, or by excavating the test pit. As I discussed, test pit is a very common process. Okay, so you can stagger in a staggered manner in 1 kilometer. Okay, so you can take the test pit, and you can just note the thickness of different layers. What is the BC thickness? What is the DBM? Everything. So our combined thickness you can take, and you should know what is the granular layers. Everything you should take from the test pit. Or nowadays non-destructive techniques also available, like GPR, ground penetrating radar survey, and all that. So as it has generally been deflected to accurately record as of all constructed layer thickness, the most effective method of determining thickness is excavation of the test pit. So test pit is a very common procedure adapted. Okay, so to understand what are the different layers and what are thickness that are there. Okay, so identification of homogeneous subsections. See, as I told, 10 kilometers, whenever you consider very clearly that, so in each kilometer you will not have the same failure. Okay, some section, maybe the first section may be fair, the second section may be poor, the other section may be good, like that. Okay, so homogeneous section, see, we cannot give the same overlay thickness for all these sections. Okay, so for minimum 1 kilometer, the homogeneous section should be made for 1 kilometer. Why we have to make for minimum 1 kilometer? Because the construction process will be difficult. Okay, so maybe you cannot decide the homogeneous section of half kilometer. Okay, so maybe the first half kilometer is very fair, the first second half may be poor and all that. So whatever the poor, whatever you get, that should be adopted for the complete 1 kilometer, because construction problems also will be there. So peak deflections are peak deflection bowl parameter, subgrade strength, design traffic layer thickness. So all these things should be taken into consideration. So basically here surface curvature index is one parameter which is one of the most important thing what it is taken into consideration. So what is the deflection what you are getting exactly below the load and at the 300 mm. Okay, so the difference of that is called surface curvature index. So that is one of the most important bowl parameter, okay, which is used. Okay, so ultimately other than the surface curvature index, okay, what is the traffic, what is the subgrade strength? The subgrade strength may not be uniform in all the kilometers. Suppose it's a 1 kilometer, you have maybe the subgrade strength may vary. Okay, all these things should be used for identification of the homogeneous sections. Other than that, a statistical technique popularly it is used. Actually, it is called cumulative difference approach. Okay, so it is used in for identification of homogeneous sections. Okay, as I told that in the previous slide, that surface curvature index, traffic, and subgrade strength. Basically, these will be taken into consideration for designing of this homogeneous section. No subsection should be shorter than 1 kilometer length, and each subsection have at least 12 deflection test locations. Now, as I told, once you take the deflections in the site, the measured deflections are normalized to a standard load of 40 kilonewton. Okay, the back calculated moduli are generally used for analysis of in-service pavement and for as a further assessment of structural condition of the pavement. Now, as I told that clearly, KGPBACK we are using. Okay. Now here the most important corrections are there. Two types of corrections for the deflections. See, basically, I will tell once again. You are going to apply the loads, okay, at falling weight deflectometer you are using, and you are going to conduct the falling weight deflectometer test at a specified locations, depending upon the type of the carriageway, whether the condition of the pavement is good or poor or fair as per the IRC guidelines, whatever they are given. But other than that, after getting the deflection data, as I told, the load will be applied in the form of raising a mass on a spring system, and always you will not get exactly 40 kilonewton. You have to correct that interpolate the data. You have to get the deflections, which should be normalized for 40 km that I have told. After normalization, okay, so basically it is most important to do this. You are back calculating the with that deflections. You have to go for back calculation with the back calculation software. So you have normalized the data. Using that normalization data, you have to use the KGPBACK software, and you have to get the back calculation values of the moduli. How you will get the back calculation? You know only deflections, but how you will get the back calculated moduli? You have to give some feed values. I will discuss about the feed values in the further slides. Okay, after getting the back calculation modulus, you have to correct them for that elastic modulus, whatever you are getting, you should correct for temperature, and that correction for temperature is for bituminous layers, and the correction what you have to apply, you have to apply temperature correction for bituminous layers and moisture correction for subbase and granular and subgrade layers. That is very much important. Here two types of, no need of confusion, we have two types of corrections. One is called temperature correction. Temperature correction is for bituminous layers. The second thing is moisture correction for granular layer and subgrade layer. Okay, so correction for temperature. Okay, so as I told earlier, it is clear that in general in IRC we have 35 degrees centigrade as the standard temperature, but field temperature may not be always 35. Sometimes it may be 36, 37 like that. So basically you have to do the correction here. The back calculation modulus of the bituminous layer obtained from field deflection survey conducted at temperature of T2 degrees centigrade. Okay, so that should be corrected for estimate the exact modulus corresponding to T1 degree centigrade. T1 here it is 35 degrees centigrade. T2 is the field one. So ET1 is equal to elastic modulus at a particular temperature, whatever other temperature other than the standard temperature can be calculated. ET1 is equal to lambda into ET2. So T2 is a standard temperature, that is 35 degrees centigrade. Now lambda, we have the formula here. So just you can these are all the things what we have in IRC 115. So just you can use, and you have to generate your once you know the fundamental concept background is, you can use Excel sheets okay, for calculation. But other than that, so as I told, temperature correction is one important thing. Other than that, we have seasonal moisture correction. See, we are not, these should be applied for granular layers as well as subgrade layers. And moreover, the critical condition is a monsoon season. Okay, moisture, see, because of rains and all that, moisture will be, because of the moisture, a lot of variation will be coming in the soil, okay, depending upon the classification and this plasticity index and all that. So even the granular layers will have some variation in its elastic modulus. So for that reason, so basically we have to calculate the subgrade modulus in monsoon season. We have to take that as a critical one. Even though you have conducted your test in summer, we need to calculate the modified. Okay, that is the reason we have E sub underscore monsoon. Okay. See, suppose let us say you here we have conducted test in see, here we have E sub underscore monsoon for both the conditions. One is in E sub, first equation is for winter season. You conducted the test in winter season, then you have to use the first equation. Suppose let us say you conducted the test in summer season, you have to calculate the elastic modulus for subgrade in the monsoon season, modified like this. Okay, so basically similarly for granular layers, you have to conduct the what is that what we call modified monsoon season elastic modulus, modified modulus. Okay, the modified modulus, why we are talking about modified modulus here? Okay, so the test may be conducted in winter or summer, but the critical condition will be you will get less elastic modulus value in what we call monsoon season. For that reason, we need to calculate for these both layers, that is granular layer and subgrade layers, we need to calculate the modified modulus, okay, using these two equations. Okay, and these two corrections will be applied for back calculated elastic modulus. Okay, and how we are going for back calculated elastic modulus to get and all that we are going to see in the by practical problem we are going to see, okay, using the software. And other than that, so what traffic basically, okay, the traffic will be varying. See, we are using in pavement design always traffic growth rate factor. Traffic growth rate factor we are using. So basically traffic will not be the same. Maybe the pavement was designed for 100 MSA, but now the traffic is 200 MSA. Now to take into consideration that additional 100 MSA, what is the overlay, what you have to lay, and all that is very much important. You know this fundamental equation. I need not to explain much. I'm just going ahead. I think so. Most of the people know this equation IRC 37 2001 itself. We have this equation, but the very fundamental things for computation of N, that is MSA, million standard axle, traffic in MSA, million standard axle. Standard axle is 80 kilonewton. So you know the commercial vehicle per day as A, and in initial before the completion of construction. So D is the lane distribution factor that according to the code you can calculate, you can consider according to the code. Vehicle damage factor, as I have told, you have to conduct the axle load survey. If it is not possible, according to IRC, you can take. So design life in years N, and growth rate for the traffic generally taken as 5 to 7%. Here it is given 5%, and other than that, suppose let us say you have you need to calculate during the construction period what is the traffic. For that, you A is equal to P into 1 plus R whole power X. That formula is there. Everything, these things I need not much explain. So, but the criteria, see, basically overlay estimation can be done in different ways, but here we are going to calculate based on stress and strains. So this is the concept IIT PAVE. Already IIT PAVE is used for a pavement design, bituminous concrete pavement design. So this lecture I have delivered last year for pavement design. But I'm going to show you how to use KGPBACK and IIT PAVE right now, so that you can understand. But see, basically, some people who doesn't have fundamentals, maybe fundamental, if you don't know, in the bituminous concrete pavement is mechanistic empirical pavement design. So basically, two failures are taken as two failures we are considering, especially according to IRC 2018. One is fatigue cracking at the bottom of the bituminous layer. Okay. The second thing is wheel path rutting. Okay. So vertical compressive strain at the top of the subgrade is taken as a critical. That strain is considered as a critical one for wheel path rutting. Horizontal tensile strain at the bottom of the bituminous layer. Bituminous layer means you have BC as well as DBM. Bottom you have to take DBM. So horizontal tensile strain at the bottom of the bituminous layer is responsible for fatigue cracking. Fatigue means repeated, and cracking, you know, repeated loads are coming on the pavement surface and failures are happening. So here NF you need to calculate. So basically we are having here epsilon T. Okay, in this equation whole power 3.89 is there. Epsilon T is there. This epsilon T you will get from IIT PAVE software. Okay, so that you have to substitute here, and other than that, here MR is there. MR is a resilient modulus. As I told, that elastic modulus in the olden days we call, now it is a resilient modulus, because resilient modulus is the ratio of deviated stress to what we call elastic recovery, that in the triaxial test setup. Okay, we have to conduct and all that. So basically this equation is used for pavement design according to IRC 37 2008. The same thing here also in this, but these two reliability equation performance criteria is considered as the same, the rutting and as well as fatigue cracking. Okay, so same equations they are using for. So finally, this is a summary of overlay design. So with this, I am going to software. Okay, explanation. So one summary is what measurement of surface reflection of a homogeneous sections. So when you go to the site, you have 10 kilometers. Based on the core section, whether it is good and all that, you decide. And moreover, based on deflection bowl and traffic and subgrade strength, you decide homogeneous section. That is very much important. So homogeneous section should be minimum of 1 kilometer length, as I told, construction problems will be there. And normalization of deflection to 40 kilometers, that is most important. So you have to do that. Then you have to go for back calculation using KGPBACK. So the KGPBACK is using genetic algorithms. It is an iterative process. You are going to give some seed values. Just I will show you the seed values. Okay, then you can understand. So adjustment of the bituminous layer modulus after getting the from the what we call back calculation, we have to go for temperature correction and what we call monsoon condition, the corrections I have told. And at last year you have some 9 sections, something like you have different elastic modulus. Okay, for bituminous layers, for granular layers and subgrade layer. So definitely you have to go for consideration of 15% modulus. So just you can do, you have set of values, you can Excel also, you can do that. And ultimately analysis of in-service payment. So you can use a linear elastic theory concept, that is IIT PAVE, whatever it is using. So this computation as I told, that horizontal tensile strain and vertical compressive strain according to IRC 37 2012. So once we do the problem, then you can understand. I will show the problem, I will show the software, okay, so that you can understand. So estimation of the remaining service life of the pavement using fatigue in bituminous layer, subgrade rating performance, okay. So these things, everything you have understood, I think so, fundamentals I have explained. So because I took a lot of time, the reason is without understanding the code, you can't do anything. So these are the references. Now I'm going to the KGPBACK IRC 37 problem, and I'm showing how to do in the KGPBACK software. Okay. Now here, basically this is the data which was normalized actually. Okay, this is the data. I think so. This is visible for all. Okay, data is visible. Participants, data is visible.
Yes, sir, it is visible.
Yes. So basically, this is the normalized data. Basically, it is existing pavement was there. Two bituminous. It is having two bituminous layers with a total thickness of 170 mm and thickness of 575 mm is there. Granular layers. Okay. Design traffic is 100 MSA, and deflections are measured at different locations of the homogeneous sections for normalized 40 kN standard load. So as I told, normalization was already completed. So they have got some other values and they have normalized. And the pavement temperature was given at the right side. As I told that the radial distance are there. So 300 mm, 600 mm, 900 mm, 1200 mm, 1500 mm. Okay. So now I'm using this KGPBACK software. Okay. So just it is a very simple. Okay. Only thing is we have to give some spacings. Okay. When you are giving the data in the KGPBACK software, I think so. Whatever I'm sharing, everything is visible. Sir, this is also visible.
Yes, sir.
Okay. So basically, this is the software. Welcome to KGPBACK program for back calculation of layer modeling for 3-layer pavement system. That is very much important. Okay, we are considering the pavement layer as 3. One is bituminous layer. Second thing is granular layer. Third layer is subgrade layer. Okay. So basically, the peak load, whatever we are considering, is 40,000. As you know that we are normalizing the data to the 40 kN load. Okay. And other than that, the tire pressure, what we are considering, if you follow the IITP software, okay, for bituminous concrete pavement with granular layers, we will give the tire pressure as 0.56. Now it is asking how many deflections you are measuring. Okay. So you give, suppose for example, 7. In the IRC problem, it is 7. So just I'm giving 7. So print radial distances where deflections were measured. Okay, where you are measuring the radial distances, it is asking. So just give 0 space here. Definitely, you have to use a space bar. Okay, so after each whatever you are giving. Okay, so just use the space bar so that the software will run in a proper manner. 0, 300, 600, 900, 1200, 1500. It is a 6 deflections or what? 1, 2, 3, 4, 5, 6. Just 1 minute. In IRC problem, whatever we are having here, we have used how many? 1, 2, 3, 4, 5, 6, 7, 1800 also there. So just so here, most important thing is once we have any we have to properly give, then only the things will go. Okay, just I'm closing, and once again we can open the software. So it is 7 deflections what the IRC problem has used. So just we'll go like with that. Okay, 40,000, and tire pressure is 0.56. Tire pressure is 0.56. How many deflections we have used? That is 7. Okay. So and then afterwards, basically at what radial distances we have measured? It is 0, 300, 600, 900, 1200, 1500, and the last one is 1800. Okay, then you give some deflections. Okay, so the deflections, for example, you got as some example I am giving 0.19, space, something like 0.204, some 0.280, 0.356, 0.641, okay. So next it is asking, give the pavement related inputs, 3-layer system, type each layer thickness from from the top. This is what it is asking. So what is the thickness of the layers? As we have discussed in this IRC problem, so it is given that, so basically the thickness of the pavement layers is existing bituminous concrete pavement is having 170 mm, and other than that granular layer it is 575 mm. Okay, so basically it is 170 and 575. We are not giving, okay, the thickness of subgrade layer. Subgrade layer, generally in ITPA software also, thickness we will not mention anything. Now it is asking what is the Poisson ratio. Poisson ratio of the bituminous concrete layer, how much it is, and what is the granular layer, and what is the subgrade layer. Okay, so generally we take 0.35. Similarly for granular layers, 0.4. So just spacing 0.4. 0.4. So it is asking what is the you have to give what is the lower and upper bound moduli. This is very much important. Okay. See, IRC has suggested in its code, okay, in annexer, okay, clearly that depending upon the condition of the pavement. Suppose if I show the code, okay. So depending on in annexer here, it is clearly mentioned depending upon the condition of the pavement. Okay. So just if you see here, if you see, I think so it is visible, granular layers combined 100 to 500 MPa. If it is a bituminous layer without much cracking, 750 to 3000 MPa. That is condition of the pavement is good. If bituminous layer is in distress condition, from fair to poor, you have to use 400 to 1500 MPa. So for example, okay, I am using these are called seed values. See, falling weight deflectometer, you are applying the load, you are getting the deflection, but seed value you have to give. Then it will use the genetic algorithm. It is an iterative process until it meets this deflection value. So it will without much error, that error also some 2% error it will accept. It will give the exact elastic model for the pavement surface. Okay, pavement layers. So basically here we have to give the seed values. Okay, the seed values, how we have to give that, I already have shown you what we call IRC code. So based on that, depending upon the condition of the pavement is poor or good and all that, depending upon that we have to give. Okay, now we are talking about elastic models of the top layer. Okay, top layer means bituminous concrete layer. If the condition of the pavement is good, I can give 1500 to 3000. But whenever you come to the granular layers, the maximum the elastic models may be up to 500. So minimum will be 100. Okay, so 100, 500. So depending upon the field CBR test, whatever you conduct, okay, so you will understand what is the CBR value, and you know some empirical relations are available in IRC 37. So you can use and you can find out the elastic modulus. Generally, elastic modulus of the subgrade layer, so will be from minimum it will be there. So 10 into CBR, you have CBR 5, for example, 50, okay, and maximum value, it should be restricted to 100 MPa, that is given in IRC 37 2018 also. So just I will give that, for example. Now you can just after completion of this, immediately you can find the results in backout file in the same directory. Use a notepad to see the results. This is what you will get. Now, if you see here, we have a file here, backout file. Okay, I can use this. I can open this in the notepad. Okay, so that is most important. Okay, just I'm opening in notepad. So whatever the back calculated elastic modulus, whatever the
chicken mutton
result is this back calculated layer moduli, whatever you're getting is. So I have given something range of 1500. What we call 3000 MPa for bituminous concrete layer. For granular layers, I have given something like 100 to 500 MPa. Okay, subgrade layer 50 to 100 MPa I have given. So depending upon the deflections, falling weight deflectometer deflections, whatever we have given, okay, so it has back calculated. But these back calculated elastic modulus, whatever you are getting, especially bituminous layer elastic modulus, has to be corrected for temperature correction. I've shown you ET1 is equal to lambda ET2. Okay. Similarly, the what we call granular layers and subgrade layers should be corrected for monsoon correction. We should not take, suppose I conducted the test in summer season, I should not take directly that granular layer elastic modulus, whatever I get. I should calculate a modified elastic modulus in monsoon season, even though I got this back calculated value which I conducted in summer season or winter season. Okay, because that is the critical thing. Even whenever we go for fundamental CVR test, we always go for 24 hours, 4 days so-called CVR value. So like that, here in the case of calculation of this back, after calculation of back calculation elastic modulus, we are going to correct these things for two corrections. One is temperature correction, and other thing is what we call monsoon correction. Now, if I show that what we call IRC 115, okay, so whatever we have done in a similar manner, left side, if you see, I have given the measure deflection 7 like that, and then afterwards layer like that, layer thickness I have given, Poisson ratios I have given, and then afterwards I have given some seed values. This is very much important because it doesn't know actually. Okay, you have given some you have got some deflections. You have normalized the deflections for whatever we call for 40 kilonewton. That's what here this data, whatever it is showing in this page, serial number 0300, it is a normalized one. Okay, for 40 kilonewton. Exactly for 40 kilonewton you will not get. You are normalized. Okay, but pavement temperature, if you observe, that is different. It is not exactly 35. But temperature correction has to be applied. This temperature correction should be applied for bituminous layers. Definitely you have to apply for bituminous layers. The reason is, see, depending upon the pavement temperature, the elastic modulus will change from temperature. If temperature is increasing, elastic modulus will reduce. If temperature is less, elastic modulus will be more. So for that reason, definitely you have to go for doing that. Okay. So you got just now by using the KGPBACK. Okay, you got some back calculated elastic modulus. Okay, that should be corrected for the temperature and as well as what we call moisture correction. This temperature correction has to be applied for the bituminous modulus, whatever you back calculated. Seasonal correction should be applied for granular and subgrade. So that has happened here. The modulus values back calculated for the 10 test points of the homogeneous sections. They are shown here. Homogeneous sections I have already discussed. So that it was shown here. So 1 to 10. So these things using the formulas, whatever empirical relations, whatever I have given in IRC 115, whatever I have shown for you, you can just have the formulas in the Excel and you can go ahead. But other than that, for these 10 test locations, 10 homogeneous sections, you have 10 values of what we call elastic modulus, or what we call 10 different values of elastic modulus of granular subbase and base course granular layers and subgrade layers. So for these things, you have to find out what is the 15th percentile moduli. So 15% moduli, you have set of values. Just you can use Excel and you can calculate. So here, if you see here, they have calculated as what we call 1112 as the final 15% moduli. Okay, and as well as 173 for granular layers and 44.3 for subgrade. So till here it is completed. Okay, but the most important section what we have to discuss is now existing pavement you have analyzed and you have decided the elastic moduluses. So how we have done? Just I'm giving one brief. Okay, first we have conducted we have gone to the site. We have understood. Okay, the site. Okay, 10 kilometers. We have decided. Okay, structural failures are there. Then we have done the homogeneous sections based on the deflection bowl and the subgrade traffic and all that. So basically, you identified the 10 homogeneous sections because I told minimum 1 kilometer should be considered, and less than that we should not consider because construction problems we will have. And ultimately, now you have understood the pavement, existing pavement. Now, how much overlay you have to go ahead? That is very much important. See the invest. You know the thickness of the pavement because you just I told as I have discussed just now. Okay, we have conducted test I told in a random manner we have to conduct one time left side of the carriageway, one side one time right side of the carriageway. You conduct rest. You took the thickness of the pavement layers. You know the thickness of the pavement layers. Now you have back calculated the elastic modulus. You have corrected for temperature. You have corrected temperature for bituminous layers. You corrected granular moisture. Then you have to use these elastic modulus and use IIT PAVE software, and you have to find out, okay, find out what is the elastic, what we call horizontal tensile strain at the bottom of bituminous layer, and what is the vertical compressive strain at the top of subgrade. Now, I think so IIT PAVE, I've given lecture in the last year, but I don't know many people should know, even though I'm just giving an idea for you, basically how to use this IIT PAVE software. It is also very simple. Basic concept is the IIT PAVE software looks like this. Okay, I think so. This dialog box is visible for everyone. Now we have 3 layers here, as I discussed, bituminous layer. So I have some back calculated elastic modulus, what I obtained in Notepad. Okay, this is 2974, for example. Okay, 2974, and I took the Poisson ratio as 0.35. Okay, next I have in Notepad my second layer, granular layer. I got elastic modulus as 500. I took the Poisson ratio as 0.4, and the last layer is the subgrade layer. Okay, as I told that we will now here, if you see here, we have to give thickness of the other layers, what we call first layer, second layer, but last layer we will not have any thickness. That's what I told very clearly. Subgrade layer we are not going to mention any thickness. Okay, so basically what are the thickness of the top 2 layers? Okay, so for example, it is 170, I think so. What I took 170 and 575. And what is the elastic modulus of the last layer, that is the subgrade layer? 57.9. I am taking 58. Okay, and what is the Poisson ratio? 0.4. And see, basically here you have to give the wheel load in newtons. Okay, so here we are giving set of dual wheels or a single wheel load, because 80 kN is the IRC standard axle. It is coming onto the 2 set of dual wheels. Okay, that is most important. We are giving a set of dual wheel. For that reason, we are taking 20,000. Okay, so it is 20,000, and moreover, tire pressure is 0.56. As I told, in the case of flexible pavement, bituminous concrete pavement, if you are considering the cement treated base course layers, sub base and base course layer, in that case you have to give 0.8 MPa. But other than that, we can take 0.56 tire pressure. Now we have to take always even though I told horizontal tensile strain at the bottom of bituminous layer and vertical compressive strain, horizontal tensile strain is responsible for static cracking, vertical compressive strain is responsible for rutting. Okay, even though 2 strains only we need, we have to take basically in radial distances we have to consider 2 distances. What is the reason? I will tell. So this is something like a depth of 170 mm at the bottom of the existing bituminous layer. Okay, and suppose let us say you have a radial distance of 0. For example, I'm taking. See, whenever we have set of dual wheels, okay, exactly at the center of the set of dual wheels, okay, that will be critical sometime. Okay, so that also we have to consider. Okay, so 310 mm is the spacing between the exactly center wheel. Okay, if you take half of that, so basically you are going to get 310 means 155 will get half of that. So at that location also you have to consider that what we call, that is also one of the critical location to calculate horizontal tensile strain. But other than that, what I am telling is, if you go, we need vertical compressive strain at the top of the subgrade. Now 170 plus 575. Now what should be 170 plus 575? Just if you see here, 170 plus 575. 575 comes around 745. Okay, so 745, and once again radial distance is 0 exactly under the tire. Okay, and at a radial distance of 155 mm. Okay, so these things should be understood. And I told that we are considering the dual wheel set. For that reason, I give it dual wheel set. Now values are successfully submitted and run. Now view here. Okay, Now here, how to observe the horizontal tensile strain at the bottom of the bituminous layer. Now if you see here, now epsilon T and epsilon R, these are the two columns under which you have to see. So these strains are critical. Okay. So if you see here, 0 point something like 103 into 10 power minus 3. Okay. So this is going to be critical. Okay. Critical value. Okay. So this value should be substituted in the what we call NF equation. I have shown you NF performance equations. If I once again go back into my presentation, okay. So I have shown you performance equations. Okay, these fatigue equations. NF should be here epsilon T. Whatever I shown you, this is epsilon T. Okay. Now epsilon T should be substituted here. You know already the back calculated value here. Now you can compute the NF value. Once you compute this, then you will get whether the existing pavement is safe in what we call without how much MSA it can carry. You can understand existing pavement. Okay, now existing pavement is something like 171 thickness of bituminous layers and 575 of granular layers. Okay, just now. So once you compute here, okay, so you are getting NF value. That is NF is permissible standard axles in fatigue cracking. Okay, now you will understand now whether I am getting now traffic of 200 MSA, whether you are getting 200 more than 200 or not. You are getting something like 150 here. Okay, for example, it is going to it is because of that it is the payment section is failed. Okay, so now you have to go for overlay. Okay, so this is most important. Okay, so similarly you will calculate for what is the what it is under what we will understand when traffic is more 200 MSA, you are getting only 150 MSA. That means that is the reason the payment was failed. Okay, that is the reason the payment was failed. Now you have to go for overlay thickness. Okay, consideration. Now once again in a similar manner, whatever I have used the whatever now just now I used the ITPAVE software, in a similar manner we have to go for running of the same ITPAVE software with 4-layer system. That is very much important. If you observe here, okay, the combination of existing payment and overlay will be analyzed as a 4-layer system to ensure fatigue and rutting criteria are satisfied for the assumed traffic, design traffic. Trial overlay thickness are selected and maximum tensile strain in the bottom of the existing bituminous layer has computed and like that. Okay, we are assuming now. Okay, see, we understood that once we run the ITPAVE back calculated, we have back calculated the resilient models or elastic models. We have back calculated. We applied for temperature and seasonal corrections, and we have took the out of the 10 values, whatever we have got, 15% value we have got, and we know the thickness by test from the test pits, and we have run the ITPAVE software, and you understood that with the strains, whatever you get from ITPAVE software, you substituted in the NF&R equations what we have in the IRC 37, and you understood that the payment section traffic is more, design traffic is more, but your NF and NR, you are getting the values are less. Okay, then you have to go for some sort of assumption of overlay thickness. Okay, that overlay thickness here in example they have told 95 mm thickness. Okay, so in now you have to consider in ITPAVE 4-layer system. What is the 4-layer system? You have already existing payment. Okay, now if I open once again ITPAVE, okay, so something like you have to go like this. Okay, so now you have to go ahead with this is a new payment section. Now you have to take 4-layer system. What is 4-layer? First layer is what you have. First layer as your overlay. Okay, so here in the example they were told that something like 95 mm thickness they are going to consider of overlay, BC overlay, and the elastic modulus of VG30 grade bitumen, what they are considered it is 1695 MPa. 1695 MPa. Poisson ratio is of 0.35. Okay, and the next layers are already existing layers. Already we know. Already we have just now we have got the back calculations. Back calculate as we have calculated for back calculation 272974, and it is 0.35. And once again here thickness is 170. Okay. And the next layer is something around 500, I think so, granular layer. We got back calculation 500. Okay, and the next layer is that is the Poisson ratio for the layer is 0.4, and thickness is 575 as the existing pavement is having. And elastic modulus, as I told that for subgrade layer, so we will not consider any thickness. So just only elastic modulus from back calculation notepad, we have it as 58 and Poisson ratio as 0.4. Here also 0.4 for granular layers you can generally consider. So 20,000, as I told, the set of dual wheel we are giving, and the tire pressure is 0.56 only. So analysis points 4, generally we take 4, because the reason is, I told, we are not just computing exactly below the tire, but at a distance of 155 mm. The reason is center to center, a dual spacing of the one dual set of the tire is 310 mm, half of that is 155 mm. So basically depth is now you have to give 95 plus 170, because the reason is you are given the overlay and you have existing BC and DBM completely. So 95 plus 170. Okay, so it comes around 265 that you have to give as thickness. Okay, so at a radial distance of 0, similarly 265. Okay, at a radial distance of 155. The reason is 310 mm is the center to center tire spacing. Similarly, now what is the vertical compressive strain on the top of the subgrade, you should know. Okay, so that is, you have to add all these things, 95 plus 170 plus 575. So you are getting around 840. So 840 radial distance is 0, and once again you have 840 and radial distance as 155. So dual tile set you have considered. So submit, and your values are submitted, and just press run. Okay, now view here. Just you can view here. Now once again you have got this strain values. When compared with the last value, whatever I took, once I added 95 mm of overlay, if you see here, earlier it is into 10 power minus 3, now the value has reduced to 0.7 10 power minus 4. That means now, because of this reduction of the tensile strain, if you substitute in that equation, definitely what we call allowable axles, standard axles in fatigue cracking definitely will increase. Okay, so that you have to compute, and you have to ensure the design traffic, whatever you have 200 MSA, then NF value should be more than 200. Similarly, NR value, how you consider epsilon Z. Okay, so it is at 840. Okay, and moreover here you have to take the negative values. So you know -1. Okay, minus 2 will be greater, negative value to take, and once again you have to substitute in the NR value, NR equation, what we have seen in the presentation slide. So if you see here, rating in subgrade. So both, see the design, whatever the design traffic, whatever you got, it should satisfy both NF and NR. Okay. So in 4-layer system in IIT PAVE, whenever you calculate and you substitute horizontal tensile strain in the first equation NF, you got more than 200 MSA of traffic. Okay, allowable in fatigue cracking, and similarly more than 200 MSA of traffic that can be allowed in rutting. Then your pavement is safe, and you can provide an overlay of 95 mm BC layer of VG30 with 1692 MPa what they have preferred in IRC 37, IRC 115. Okay, so this is how you have to go for structural evaluation of falling weight deflectometer using IRC 115 and using what we call KGPBACK and IIT PAVE software. My presentation is a little bit detailed, and it went around, I think, so 1 hour 45 minutes. I'm very much sorry to say, because I want to make you to understand the code much. Without understanding the code, and you cannot, even though I tell these two softwares, there is no meaning in explaining these two softwares. So lot of practical experience is needed to analyze these things, and I am very much thankful actually to say to Raja Kumar. Okay, and moreover Professor K. Sudhakar Reddy sir, his valuable research recommendations are there in this IRC 115 to develop the code, and ultimately my department civil engineering, GMR Institute of Technology, Rajam, so for giving the technical support. So audience, I think so it is a long presentation which your patience. I am much more thankful for all the people who are joined here for your patience. The falling weight deflectometer analysis for structural evaluation of bituminous concrete pavement already done by Professor Satish Chandra, IIT Roorkee, ex-professor. So he is with CRR, I think so. So other than that, Anush K. Chandrappa has given for GMRIT. Okay. So in one workshop called as a design and construction practice of sustainable concrete sustainable pavements, he has given his lecture. I think my presentation maybe something it went in slow manner. That is the reason some participants left. Okay, but if I don't give in a detailed manner, I thought it will not be that much useful, because I can explain KGPBACK and IIT PAVE within half an hour and I can close. Audience.
Thank you so much, sir.
Raja
Thank you
sir.
so much, Sivaram. Yes, sir. Thank you
Yes,
so
sir.
much, sir. You have given me a continuously the detailed session, insightful session.
Yes,
So
sir. Yes,
everything you
sir.
have
I
covered, each
want
and every
it to
part
make
you have
like that
covered.
only, because a lot of things to be considered, sir. That is, I want to make them understand, whoever attend my session.
Yes, sir. Yes, sir. Thank you so much, sir. Audience, if you have any questions, you can ask the speaker.
Thank you, Siva. This is Sheikh Mastan. I hope you remember me.
Yes,
We were together
Mastan, sir.
for
How are you?
Yeah.
How are you?
Yeah, good. Yeah, it's a really very nice session. You
Okay.
covered most of the practical theory all together. And
Yes.
right now I'm in Qatar. We widely using this FWD test.
Okay.
Whenever we are
Nice.
not
Nice
getting
for
the
joining
enough
this session.
data,
First of all, sir.
whenever there is a missing in the testing, we are going to analyze it. Apart to that, we are using the latest GPR systems to analyze the payment in detail.
Okay.
And your session is really covered. I'm really appreciate India also going ahead with the developing nations like US also.
Yes, sir. And now India is constructing many expressways and national highways.
Yeah, that's true. So I want to understand two things here: whether this test is the stress controlled or a strain control. That's one thing. And whenever we apply this test for this unbound material, normally what you call as granular, some payments where we have the cement-based sub-base layers. There we have more variation in the test stages.
Yes. Actually, whenever you have cement-based layers as granular layers, definitely a lot of variations will be there. Okay.
So finally, we decided not to go for the cement-based layers. Now we are applying only for the
some sort of developments also will come regarding that. I think so. So exactly, because my time constraint, I could not give in more detailed explanation. Sorry to say. So because I could have covered more in-depth technical items. Okay. But I want to understand. I want the people who have joined all should understand this Falling Weight Deflectometer analysis in a very detailed manner and very simple way. So that is the reason I made this presentation. Some of the technicalities definitely are there because IIT professors are also working on this. So thank you, Mastan sir, for joining the session, because you are in advanced country.
Yeah, I took time to attend your seminar.
Thank you so much for wonderful participation.
Thank you so much, Mastan sir.
Thank you. Welcome.
Sir, he has worked with me for Hyderabad Outer Ring Road as quality control engineer, sir. He is a senior quality control engineer for Hyderabad, the Dundigal Shamirpet section.
Oh, nice,
okay.
sir. Nice, sir.
Good. I have worked along with him. Nice, sir. Nice, sir.
Actually, sir, if you are able to give any session, sir, we will conduct with you, Mastan sir, for you, with you also, sir.
Mastan sir will give, sir. He is expert, sir.
Yes, sir. Yes, sir. Actually, our mission is to actually, if you see in the industry, expert becoming the more expert by learning new things. But nowadays, because of busy schedule or I'm not having time on some other things, the knowledge is not being shared through the expert. That's why we started this platform as a part of our social responsibility, sir.
So it's really nice. I appreciate. Really, it's a very nice session, and you are doing good job.
Yes, sir. Thank you, sir. So if you have any experts, also if you
sure. I will
Mastan sir, try to give some innovative techniques what in Qatar practice of innovative techniques what they're using on highways and all that. Some presentation, half an hour to 45 minutes presentation also, they will feel very happy, because this platform, Raja Kumar is completely a passionate industry person who is doing a lot to students actually. So continuously he used to post regarding the jobs, technical sessions he is organizing. You can follow www.constructionleaders.in. He is doing a lot.
Yeah, sure. I'm following it.
Okay,
thank you. Thank you, sir.
Thank you.
Thank you, sir.
Thank you all.
And thank you, participant, for attending the session.
Thank you. Most welcome.
So soon we will conduct many more sessions, sir. Different topics we are trying.
Sure,
to
definitely.
and the recording sessions also we are uploading in the website, sir. If anybody missed the session also, they can
Yeah,
watch
they
the
can
website.
follow it. Yeah, thank you.
Raja sir,
Yes.
actually one paper that is IoT and digital twin application civil engineering, if it is accepting, no, I'm going to give that presentation thoroughly. I will go ahead and I will do that for you.
Yes, sir. Definitely, sir.
IoT and digital twin, that is a new, entirely new concept. So civil engineering applications, that
Yes,
is
sir.
good
We
one.
can plan one session on.
Yes, we can do that.
We can, yes, sir. Yes, sir. Yes, sir. Sir, Mastan sir, actually, sir, you have Mastan sir contact number, sir, to approach him.
I share
I
with
have his
Shivakumar also.
WhatsApp and all that.
Yes, sir. Yes, sir. Please share me, sir.
Mastan sir, you can ping your
we will,
number, sir, once. Mastan sir,
Sure, definitely. I will share. Shiva.
you can share your number.
yes, sir. Thank you, sir. Thank you so
Okay,
much, sir.
thank you.
And I think any more questions from the participants?
Participants, you
ask,
can just discuss, because I'm not much expert, but I can whatever I can, so you can resolve your doubts and all, small doubts and all that. I think so. My presentation is in a detailed manner. That is the reason many people left.
It's not like that, sir. Really, you have been delivering excellent technical session, I can say. We are
Yes.
really have been enjoying the session.
This is a
Thank
1 hour
you.
45 minutes. Some patience also needed, but I don't know.
Obviously.
Now it is Sunday, no? It is also Sunday and all that.
yes, sir.
Any other can
Yes, sir.
definitely can ask some questions. We can discuss so that whatever the extent I can answer, definitely I will answer.
Yes, sir. Yes, sir. So, participant, can you please fill the that feedback form we have shared in
Feedback form, that
the
is
chat
very
box?
much important.
Yeah. Why? Because it will make us to improve ourselves from the next sessions also. So, if you have any suggestions, also you can give. So,
It's a
so
open
actually we have
forum. It is
yes,
nothing. Just you can
yes,
give your suggestion. Open forum. This is something you can talk right now.
yes, yes. Actually, we have started this platform to provide the industry and academics gap also there, and also to make everybody to get a knowledge by connecting all the seminars in the industry experts and everybody like that. For that reason, we have started in 2021. So as of now, we are conducting webinars and workshop also. We have done one BIM workshop also, workshop and the course also. So soon, upcoming days, we'll come up with many sessions. And thank you for joining the sessions.